Good afternoon and welcome. Today we want to talk a little bit about how the standard deviation and the mean can help us understand what a distribution looks like. And in particular, if a distribution is normal, what do the mean and standard deviation tell us about how the data is spread out? Can the mean and standard deviation help us figure out, say, what are really likely observations? What does a typical observation look like? To help us do that, we're going to look at the following example. The cars in the parking lot have a distribution that is approximately normal with a mean of 23 miles per gallon and standard deviation of 2.5 miles per gallon. And we will use the 68, 95, 99.7 rule to help us make a few calculations as to what types of measurements, what types of fuel economies we would expect a car to have. So, first thing I want to just mention here, we often say that instead of being normal with mean 23, standard deviation 2.5, we often abbreviate this with normal as an N 23 2.5 to save writing all of this out. Now the next thing we want to look at is what does this distribution look like? Now recall that a normal distribution, it has a bell-shaped, it is symmetric. It is also a specific type of distribution, and because it is a distribution, the area underneath the curve adds up to 1. And further, the area between any two x values on the curve represents a proportion or probability. So here is one normal distribution. So on the x-axis, we have miles per gallon. Here is a bell-shaped. First thing we want to look at is what the mean represents on this curve. Remember that the mean is the center. It is a measure of center, so the mean in this case is 23. Now the next thing that is a little bit harder to find on this graph is the standard deviation. Physically, the standard deviation is what we would call a point of inflection. It is actually the point on the graph where the graph goes from cup-shaped upwards to cup-shaped down. Notice that there are two places where that happens. This graph is symmetric, so those are reflections of each other. And this point is one standard deviation away from the mean. Now, in this case, that one standard deviation is 2.5 units. And if we were to go the same 2.5 units in the other direction, we have one standard deviation to the right. The x values here, 23 plus 2.5, gives us 25.5 miles per gallon here on the right. And on the left, 23 minus 2.5 gives us 20.5 miles per gallon on the left. Now, if we were to go to a table of z-values, we could actually compute that the area between these 2 points, because it is a normal distribution, the area between 20.5 and 25.5 is approximately 0.68 or 68%, hence the 68 in the 68, 95, 99.7 rule. So what that rule says is that approximately 68% of, in this case, our fuel economies are between 20.5 and 25.5 miles per gallon. So that tells us that 68% of the cars, 68 out of the 100 cars out there in the parking lot, have between 20.5 and 25.5 miles per gallon. On the other hand, that also means that 32% get less than 20.5 and greater than 25.5 miles per gallon. So let's go a little bit further. In the 68, 95, 99.7 rule, the 95 tells us that approximately 95% of the data falls within 2 standard deviations of the mean. So in this case, one standard deviation is 2.52 would be 2 times 2.5 or 5. So if I go 5 units to the left and 5 units to the right, I get to 28 and 18 respectively. So we could say that 95% of the fuel economies are between 18 and 28 miles per gallon. So how does that help us out? Well, if we were to go out and say find a car in the parking lot that got 30 miles per gallon, we might wonder, is that likely? Is it likely that a car gets 30 miles per gallon? And what we see right here is that, well, 30 is outside of 28, so there's only 5% of all of the cars getting greater than 28 and less than 18 miles per gallon. On the other hand, a car that gets, say, 27 miles per gallon, that's quite likely because it falls within this range between 18 and 28, in which 95% of the cars get between 18 and 28 miles per gallon. So we can see that the 68, 95, 99, 7 rule gives us a very good feel for what types of fuel economies are typical and which ones are somewhat unusual. We could go on and use the third part of the rule that says that 99.7% of the data falls within 3 standard deviations of the mean, but I will leave that one for you to do on your own.